Hey guys, we are going to go ahead and move forward into lesson 4. In our title, writing products as sums and sums as products almost sounds like a riddle, but it's very simple. And we know that a product is when you're multiplying two objects or two numbers or even two letters. And in this case, in example 1, we have 2 times the quantity of x plus 5. So when we multiply that through, we actually get a product. So let's try this. 2 times x and 2 times 5. So we would get 2x plus 10. All right, let's try the next one. 3, we're just simply using the distributive property here. And we would have 3 times x and 3 times 4. So we wind up with 3x plus 12. The next one, we again using the distributive property, 6 times x and 6 times 1. We have 6x plus 6. I want you to try the next one on your own. This one looks a little different because we do have a subtraction sign, and that's okay. We just roll with it. Again, I hope you got 7 times x, which is 7x, and then 7 times the negative 3. So that would be a negative 21. And it just reads 7x minus 21. All right, now we're going to work backwards a little bit. And at some point in your higher maths, we'll do some factoring. And this is basically all this is. And we factor when we have multiplication with fractions a lot of times. I know y'all can recall we just did that yesterday. And if we're looking at 5x plus 30, what do I know about 5x and 30? What did they have in common that I could factor out? We have a 5 that's in common. So if I factor 5 out of 5x, I'm left with what? That's right, I'm left with x. If I factor a 5 out of 30, what am I left with? And that's just simply saying 30 divided by 5, which leaves me with 6. So now I have written this, the sum, as a product. Okay, let's try the next one. What do we know that 8x and 8 have in common? That's right, they have an 8 in common. So I'm going to factor an 8 out of each term. And if I factor an 8 out of 8x, I'm left with just the x. And if I factor an 8 from 8, in other words, I'm just saying 8 divided by 8, I have an 8, or excuse me, I have a 1. Let's try the next one. What does 3x and 12 have in common? They have a 3. Alright, so let's factor a 3 out. 3 divided by 3, we have x. Don't change your sign. We have a negative sign or a subtraction sign. And a negative 12 divided by 3 should give me 4. Now, I want you to try the last one on your own. $15x and 20, it's a little different. We have, what do they have in common that I could factor out? We have a 5 that I can factor out. 15x divided by 5 leaves me with 3x plus 20 divided by 5. I have a 4 left over. Very good. Now let's go to exercise 1. Rewrite the expressions as a product of two factors. And again, we're just doing the same thing we did right here on E, F, G, and H. Okay. 72t plus 8. If I'm going to write that as a product of two factors, it's going to, like I said, it's going to look just like E, F, G, and H. So I need to find out what 72 and 8 have in common. And I think they have that 8 in common. So if I factor an 8 out of, or divide 72t by 8, let's see, is that 9? I'm left with 9t plus 1. Okay. I'm going to let you do C and E by yourself. Give you a chance to practice on those, and I'll come around and check your work, okay? Moving forward to example 2, we're going to, let's just read through the directions. And it states, let the variables x and y stand for positive integers, and let 2x, 12y, and 8 represent the area of the three regions in the array. We need to determine the length and the width of each triangle if the width is the same for each rectangle. All right, and this first statement, in other words, is saying, hey guys, there are no negative signs or negative integers up here or for x or y. So first off, let's look at what we actually have for the area of each section of the array. We have a 2x, a 12y, and an 8. What do I know about 2x, 12y, and 8? In other words, what do they all have in common? Yeah, they have a 2. So I could factor out a 2 from each section. If I do that, if I say 2x divided by 2, I'm left with 1x. The same for 12y. If I divide 12y by 2, I'm left with 6y. Okay. And 8 divided by 2 leaves me with 4. We just factored that 2 out of 2x, 12y, and 8. Okay, let's try exercise 2. We're writing the product of the sum of the expressions being represented in the rectangular array. Write the product and sum of the expressions being represented in the rectangular array. Right off, I'm going to go straight for the area, what's already given to me in the interior part of that array. I know that I'll have 24D plus 8E plus 6. Now, I also know that this is considered my length. This 2 is considered my length. And all of this up here on the top is considered my width. It's just like saying length times width when you're trying to find the area of a rectangle. Okay, guys? So I know that I can rewrite this again as 2 times the quantity of what would be in my parentheses, and this up here on the top is what would be in my parentheses. So I would have 12D plus 4E plus 3. And we can run through here and double check ourselves. 2 times 12D, 2 times 12 is 24, so check, that gives me 24D. 2 times 4E would give me 8E, and 2 times 3 gives me the 6. So I feel pretty confident with what I've got there. Exercise 3 states, for each expression, write each sum as a product of two factors. Emphasize the importance of the distributive property and then use various equivalent expressions to justify equivalency. So I'm going to work A, D, and G, okay? And then I would like for you to solve on your own B, C, E, F, H, and I, okay? So let's look at part A. So we're writing each sum as a product of two factors. What does 2 times 3 and 5 times 3 have in common? They have a 3. So I'm going to actually set this up as 3 times the quantity of 2 plus 5. So all we're doing here is looking for what these sums have in common, and that's what we're going to multiply by. That's what we're using the distributive property with, okay? So let's try D. Again, x times 3 plus 5 times 3, and again they have a 3 in common. 3 times x plus 5. Okay, and G, x times 3 plus y times 3. They still have that 3 in common. And I want to check to make sure that we are correct with our equivalent expressions, okay? So all we're going to do is go through and do our calculations, and I'm going to do A down here on the bottom, okay? We have, I'm going to rewrite my problem, 2 times 3 plus 5 times 3. I'm just going to go through, I'm going to add, multiply and add it all up. So 2 times 3 is 6 plus, and what's 5 times 3? That is 15. And 15 plus 6 is 21. Okay, so I'm saying that 3 times the quantity of 2 plus 5 should give me 21 as well. So let's try that just right over here. 3 times 2 plus 5 should give me 21. Now, I do what's inside the parentheses first, according to PEMDAS. So 3 times 2 plus 5 is 7. 3 times 7 is, in fact, 21. They are equal. Check. I know that these two guys are equivalent, and I know that my equivalent expression that I came up with here is correct. Now, I'm going to give you a few minutes of class time to work on these over here. Again, B, C, E, F, H, and I. Moving on to example 3, let's read through our story problem here. We have a new miniature golf and arcade opened up in town. For convenient ordering, a play package is available to purchase. It includes 2 rounds of golf and 20 arcade tokens, plus $3 off the regular price. There's a group of 6 friends purchasing this package. Let G represent the cost of a round of golf and let T represent the cost of a token. Write 2 different expressions that represent the total amount this group spent, and then explain how each expression describes the situation in a different way. All right, I'm going to go back up here to my story problem, and I'm going to underline some key terms and phrases up here. And my first one is that I know we're playing 2 rounds. And then The second one, we have 20 arcade tokens. The next, we know that we've got $3 off the regular price. Let's see, we know that G is going to represent the cost of a round of golf. T will represent the cost of a token. And then we're going to write two different expressions. Oh, I see something else I missed. How many friends are going? We've got 6 friends that are going. So I'm going to come over here, I'm going to make a little key, and we have 2G, because we know we're playing 2 rounds of golf, and G represents golf, right? Equals how much golf we played. How about the tokens? How many tokens did we get? 20 tokens. And what does T represents the tokens? So how many tokens did we have? We had 20 tokens, but we don't know how much that's going to cost. Equals tokens. Okay. We had 6 friends. And we got a $3 discount. That one's key because I want every discount I can get. So minus $3, and that's my discount. Okay. So I want to write an expression that would give me a total cost here. I don't know the cost of my golf, and I don't know the cost of the tokens, but I know that I'm going to play 2 rounds of golf, and I know that I'm going to purchase 20 tokens, and I know that 6 friends are going, and I know that we all get that $3 discount. So my first expression would be, since there are 6 friends, and each person has to pay the same amount, we're going to multiply that 6 times all of this other stuff, okay? So 6 times 2G plus 20T minus $3 because everybody gets that discount. Okay, so there's one expression. There's one. All right, let's try the next one. How can I write another expression? I can just use the distributive property and carry that 6 through what's inside the parentheses. So 6 times 2G would give me 12G plus 6 times 20T would give me 120T. And 6 times the negative 3 would give me a negative 18. So either one of these, so this is my second expression, either one of these would give me a total for how much each person would pay, okay, or how much everybody would pay together, because you're going to, that's for 6 people. All right, let's go ahead and go to exercise 4, part A. This is kind of a funny question. What is the opposite of the quantity of negative 6v plus 1? It's just like we did a couple of lessons ago. What's the opposite of 1? Negative 1. Opposite of 2? Negative 2. So we would take the opposite of everything that's inside that parentheses. And the way we would do that, legally, a legal move, yeah, we could look at this and say, okay, the opposite of 6v is a positive 6v, and the opposite of 1 is a negative 1. But our legal move that says we can do that, we take a negative 1 and multiply it by everything that's inside those parentheses. So we have a negative 6v plus 1. Now, doing this, again, we're just using that distributive property. A -1 times a -6v is a positive 6v. A -1 times a positive 1 gives me that -1. Again, we just multiplied that -1 times everything that's inside the parentheses. Okay. I think I kind of jumped ahead of myself here. But let's go ahead and, it says using the distributive property, write an equivalent expression for part A. That's okay. So one equivalent expression would be 6v minus 1. And some of you may still be using this way to write it as well. 6v plus a -1. And that's okay too. All right, we're going to go ahead and move on to example 5. This is example 5 right here. I think I just got that cut off just a little bit. That's okay. All right, rewrite 5a minus the quantity, or excuse me, minus the quantity of a minus 3b. Let me start over with that again. All right, rewrite 5a minus the quantity of a minus 3b in standard form, and then justify each step applying the rules for subtracting and the distributive property. Okay, so basically all we're going to do is, I'm going to rewrite this, 5a minus a minus 3b. Okay. That goes in parentheses. So remember here, it's just like we have an invisible 1 right there. And I'm going to take that invisible 1 and I'm going to multiply him times everything, and he's actually a -1. A negative, that invisible -1, multiply him by everything that's inside the parentheses. So I'm going to rewrite him over here. 5a minus a plus 3b. Okay, we're okay so far? All right, so, oops, I left my a off. 5a minus a would leave me with what? 4a plus 3b. Just bring that guy down. All right, and we have no other like terms because we have 4a and 3b. They are unlike terms, so this is as far as I can go. Let's try A in exercise 5. Expand each expression and collect like terms. Basically, we're just using that distributive property again. So we're going to have -3 times 2p minus, let's rewrite him as an addition statement. So let's say add, we're going to add or plus, let's see, how would we write that? -3 times a -3q. Okay. This is called the expanded form, okay, right here. So now that we've got it in expanded form, we can go through and just go ahead and do our multiplication and then collect like terms where we need to. -3 times 2p would give me a -6p plus, what do we have here? A -3 times a -3q, and we wind up with 9q. All right, can I go any further? No, because that's a p and that's a q, and they are considered unlike terms, so we are finished with that guy. Okay, let's go to B. Let's try B. He's a little wackadoodle because there are no visible integers in here, but we do have those invisible ones that would be right in front of the variable. There, 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 and there. So let's rewrite him in that expanded form, and we would have negative a plus negative 1 times a plus that negative 1 again times a negative b. Okay, let's go through, do our multiplications again. So we have negative a plus a negative a plus, and that's going to make it a positive b, right? Because we have a negative 1 times a negative b, and he becomes a positive b. All right, now we can combine some like terms. So we have a and a negative a and a negative a. They are like terms, so we can add those two together, and we have how many negative a's? We have 2 negative a's. Plus, I'm just going to bring this guy down because he doesn't have anything to combine with. So we're left with a negative 2a plus b. Okay guys, that concludes lesson 4. Your next slide on your PowerPoint will be your homework. If you have any questions, please feel free to ask, and good luck.